Hello everyone, thank you for joining me today as we discuss solving proportions. Our objective for this lesson is to do exactly that. We'll do it by cross-multiplying, and we'll also identify extraneous solutions. We solve proportions by cross-multiplying. There's an example of that shown on the right where we find the cross products in blue and in red. We set them equal to each other and we solve what's left. Sometimes solving what's left is a matter of just a couple algebra steps. Sometimes it's more involved where we actually have to factor. Whatever's left, we'll solve it however we need to, and once we get our solutions, we'll check them because we may get some extraneous solutions. These are solutions that do not work in the original equation. They result from our cross products, but they don't work actually in the original proportion. So let's do some examples. Let's start with x plus 3 over 4 equals 2/5. Okay, we find our cross products. We take 5 times x plus 3 and 2 times 4, and we set them equal to each other. Okay, there we have cross multiplied. Now we've got to solve. So let's simplify a little bit. 2 times 4 is 8. On the left-hand side, we'll have to distribute this 5 so that we can solve for x. No factoring required here. This is just a kind of two-step equation. We have to now subtract 15 from both sides and divide by 5 on both sides, giving us a solution of negative 7/5, negative 1.4 if you prefer decimals. In terms of checking whether that's extraneous or not, okay, we'll talk about this a little bit later, but really we just have to check the denominators to see if this is one of our restricted values, a value that would make a denominator equal to 0. Here, the denominators in our proportion are 4 and 5. They don't have any variables at all. So I'm not really worried about this being extraneous. I could still check it by plugging it back in and seeing if it satisfies the proportion, or I could check graphically, which I'm going to do right now. Okay, graph both sides of that proportion. I have x plus 3 over 4 graphed, that's that blue line. I've got 2/5 graphed, that's the green line. Where those lines intersect will be our solution, and notice the x-coordinate is negative 1.4, or negative 7/5. So we can check our answer graphically by graphing both sides and finding the intersection point. Let's look at something that's going to challenge us maybe a little bit more. Here we have 4 over x equaling 6 over 3x plus 2. Let's find the cross products. We'll have 6 times x and 4 times 3x plus 2. Make sure that you use your parentheses when necessary, and they are necessary here. When we do 4 times 3x plus 2, we have to distribute that 4 to both of the terms in that expression. When we do so, we will have 6x equals 12x plus 8. Here we'll get all the x's on the same side. Maybe I'll subtract that 12x over, giving us negative 6x. And now divide both sides by negative 6. We'd get negative 8 over 6. That simplifies down to negative 4/3. I won't take the time to check this graphically in the attempt to keep this video a little bit shorter. Okay, so 2 good examples to start us off with today. Not as complicated when it came to the solving step, but still good practice for us to get the mechanics of the cross multiplying. Okay, we haven't had any extraneous solutions yet. Here in the example on the right, negative 4/3 will be just fine. It won't make either of our denominators 0 when we plug it in, so I feel good about it. Let's jump to something that might challenge us a little bit more. I think this one will do that. So the idea here is still the same. We will still solve using cross multiplication. The cross products here are going to be a little bit more complicated. We've got to take x minus 5 times x minus 1. 4 times 8 isn't that complicated, but x minus 5 times x minus 1 requires us to FOIL. So we FOIL that out, just like how we had to distribute on the previous examples. I'm going to kind of combine multiple steps into one. When you FOIL and combine like terms on that side, you will get x squared minus 6x plus 5. And now we have one of these quadratic equations, which we have solved previously in this course. We've got a few different options for solving this, right? Quadratic formula, potentially graphing, potentially factoring, completing the square if we really felt like going that route. I don't think square roots would work well because that linear term 6x will throw things off. I'm going to try factoring because I think that's the fastest, but in order to do so, I have to get all the terms on the same side. So I'm going to take that 32 and subtract that over to the left. That's going to give us a minus 27 here. And now I'm going to try factoring this. You definitely could use some of those other techniques. When something is factorable, I think factoring is the fastest. At least it is in my case, I guess. So we need factors of negative 27 that add up to negative 6. You might have to think about that for a little bit, but there are such factors. Negative 9 and positive 3 would work. So if those are our factors, recall then that we take our factors, we set them equal to 0 and solve them. You may be able to perform this step mentally, and that is just fine. I'm writing it out. Over here, we would have to add 9 to solve. Here, we would subtract 3 to solve. Here we have two solutions, which can happen when we solve proportions. I mean, here we FOILed and got a quadratic, so getting two solutions hopefully wasn't much of a surprise. To check them if they're extraneous, remember, it's the denominators we have to worry about. I'm going to, take my algebra for being correct. I have to check to see if either of these are restricted values. Well, look at our denominators. 8 doesn't even have a variable in it at all. There's no restriction there. Here, the only restriction would be positive 1. 1 would make that 0. 1 would be extraneous if we had it as a solution. We don't. We have 9 and negative 3. So neither of my solutions are extraneous. I'll leave them in the box. 9, negative 3. Let's do one final example. This one will end up being fairly similar to the last example, but still a good chance for you to maybe pause the video and try this on your own and then see if your answer matches with the answer that I get. Here we go. We need our cross products. N plus 4 times n minus 2. That will equal 3 times negative 3, which is negative 9. We FOIL. And I'm going to FOIL and combine like terms all in one step here. We'll get n squared plus 2n minus 8, and that still equals negative 9. Another quadratic here, so we'll have to use one of our quadratic solving techniques. The quadratic formula, graphing, completing the square, factoring, right? I'm going to try factoring again, and that means that I need all the terms on the same side. So like we did previously, let's bring this negative 9 over by adding it, and that'll give me a 1 here. To factor this, I will need factors of 1 that add up to 2. Well, 1 and 1 will do the job. You can imagine taking our factors, setting them equal to 0. In both cases, we would get solutions of negative 1. Here we have another example without an extraneous solution, which I don't think is very fair. We better do one that has an extraneous solution. So if you'll bear with me here, I want a little bit more. Consider negative 3 over x equals x minus 3 over 2x. Consider this proportion right here. Let's cross multiply. So that's the original problem. I'll switch colors now to stand out. Okay, negative 3 times 2x is negative 6x. On the other side, we need to take x times x minus 3. We'll have to distribute that x in order to solve for x, which takes us here. Once again, we have ourselves a quadratic equation. Once again, I'm going to try to solve by factoring. So I'll get all the terms on the same side by adding that 6x over. And when we add 6x to negative 3x, we'll get 3x. Although this is only a binomial, it's still factorable. There's still a GCF that we can take out. Take out an x. We're left with x plus 3. And now when we set our factors equal to 0 and solve, we'll get two solutions. We'll get 0 from the factor on the left and negative 3 from the factor on the right. Zoom out so we can see the original problem there. Now this is an example where we do have an extraneous solution. One of the solutions we got, it worked when we did our cross products, but it does not work in the original equation, in the original proportion. If you look back at our denominators here, I think we have a restricted value. The restricted value here is 0. 0 would make this denominator 0. It would also make this denominator 0, and we can't have that. So since 0 is a restricted value, the solution of 0 is extraneous. So we cross it off. -3 is perfectly valid though, and so I will put that inside of a box. So there is one example where we do get an extraneous solution. We identify it by checking the denominators to see if that solution is a restricted value. So there we just discussed how we can solve proportions by cross multiplying. We also identified some extraneous solutions. Thank you for watching.